Hi guys, today we're going to look at solving linear trig equations. So it starts out solve for, and this x should be theta, in the interval 0 degrees less than equal theta less than equal 360 degrees. And our equation is 2 cosine theta minus 1 equals 0. Now, how on earth do we solve this? Well, it starts out very much like solving the equation 2x minus 1 equals 0. We would add 1 to both sides, and we'd have 2x equals 1, and then divide both sides by 2, and x would equal 1/2. This is where we would be done in a traditional linear equation. But notice, if we do this in a linear trig equation, we have 2 cosine theta equals 1, divide both sides by 2. Now we have cosine theta equals 1/2. We have not found the angle yet. So we're only part done. The majority of our work is still yet to come. Okay, so this is where solving linear trig equations is different. So now we have to stop and we think, and we're going to think about our special angles. The first thing we look for is a reference angle. And we say, okay, the cosine of what angle is 1/2? Think about your special charts or have it open next to you so you're ready to go. The cosine of 60 degrees is 1/2. Now notice the domain we were given was in degrees, so my answers are going to be in degrees. So that's our reference angle. Again, it's not our answer because we know, since all students take calculus, that cosine can be a positive 1/2 in both the first quadrant and the fourth quadrant. Now in the first quadrant, it's nice and easy. The angle is the reference angle. So we would have an angle of 60 degrees. If we're in the fourth quadrant, however, and we're 60 degrees away from the x-axis, which is 360 degrees, we have to figure out how far around did we go. So we would say 360 degrees minus 60 degrees is 300 degrees. Now we have our second angle. And now we can say that theta can be 60 degrees and 300 degrees. So notice in traditional linear equations, we only get one solution because it's x to the first. And we know with polynomials of first degree, we only get one solution. Trig equations are not polynomials. We can get more than one solution. We could have one solution. We could have no solutions. We could have two solutions. We could have many, many solutions. And in actuality, there are an infinite number of solutions, except I restricted the domain to only look for the solutions between 0 and 360 degrees. Okay, so here we go. Our first one solved. Let's break down the process for you a little bit more so that you're a little clearer on what to do with each step. So again, I'm going to keep the domain for this one in degrees so that you're a little simple. So here are our steps. We're going to solve the equation for the trig function just like any other equation. So if I give you this equation, 3 times the quantity tan theta minus 2 equals 2 tan theta minus 7, that's very much like solving this equation. 3 times the quantity x minus 2 equals 2x minus 7. So the first thing we do is we distribute the 3. 3 tan theta minus 6 equals 2 tan theta minus 7. Now we might subtract the 2 tan theta from both sides, which will give us tan of theta minus 6 equals negative 7. Then we can add the 6 to both sides so that the tangent of theta is negative 1. Okay, that's all step 1. Now step 2, ignore the sign. Ignore whether it's positive or negative. So when I'm finding this reference angle, I say the tangent of what angle is positive 1. The tangent of what angle is 1. And I think about my special charts, that's 45 degrees. Now we use the fact that this is negative. Now we're using this sign. And the fact that I know that all students take calculus, tangent is negative in the second and the fourth quadrants. If we're in the second quadrant and we have a reference angle of 45 degrees, That means we're 45 degrees before 180 degrees. So we do 180 degrees minus 45 degrees, and that is 135 degrees. If, however, we're in the fourth quadrant with a reference angle of 45 degrees, that means we're 45 degrees before 360 degrees. Because remember, it's always the distance to the x-axis, the quickest distance to the x-axis. So 360 degrees minus 45 degrees is 315 degrees. I now know that theta can be 135 degrees or 315 degrees. And again, I've got two solutions to a linear equation. Will that always be the case? Nope. And I'll show you one. Let's take a look at 4 sine theta minus 1 equals 2 sine theta plus 1. So first step is solve it like any ordinary equation. Okay, so we're going to add 1 to both sides. And I get 4 sine theta equals 2 sine theta plus 2. Now I'm going to subtract the 2 sine theta from both sides. And I get 2 sine theta equals 2. Divide both sides by 2. And sine theta equals 1. Now here's the catch. There is no reference angle. When sine and cosine are 0, 1, or negative 1, those are not angles that are inside quadrants. They are quadrantal angles. Think about your sine graph. The sine of 0, 90, 180, 270, 360. When did it have a height of 1? That happened at 90 degrees, or pi over 2, depending on our domain. And there we go. That's it. One solution for this particular problem. Now, in number 7, the next example, I'm going to change the domain to be from 0 to 2 pi. So now you're going to have to give me your answers in radian form. So that's the only difference with this problem. Okay? So here we go. We start solving like normal. I'm going to subtract sine theta from both sides. So I have 2 sine theta minus radical 3 equals 0. I'm going to add radical 3 to both sides. So I have 2 sine theta equals radical 3. I'm going to divide both sides by 2. So now sine theta is radical 3 over 2. Now we ignore the sine and we find a reference angle. Now, to connect this to what we were doing the other day, remember, if we were going to keep solving, we did subtraction of sine because the inverse of adding was subtracting. The inverse of subtracting radical 3 was adding radical 3. The inverse of multiplying by 2 was dividing by 2. So the inverse of sine is sine inverse, okay? And that's what we're doing. But notice, this is lowercase arc sine of radical 3 over 2. If you use your calculator is going to do capital arc sine. Do not put a negative into the calculator and think you have your answer. It will not do it correctly for you, okay? So we think about our reference angle. What angle has a sine of radical 3 over 2? That would be 60 degrees, or remember we're in radians, that's pi over 3. Okay, now we think about our positive or negative. We know that all students take calculus, and since sine theta was a positive radical 3 over 2, that means we can be in quadrants 1 or 2. Now we like when it's in quadrant 1 because that's easy. It is the angle, the reference angle, pi over 3. So we've got it. If, however, we're in the second quadrant and we have a reference angle of pi over 3, how close is that to pi? Now we use the same denominator. Pi is 3 pi over 3. So we say 3 pi over 3 minus 1 pi over 3 is 2 pi over 3. Now some of us don't like to work in radians. That's okay. You say, okay, 180 degrees minus the 60 degrees, that's 120 degrees. Now you have to take your 120 degrees, multiply pi over 180 degrees. That's 120 pi over 180, and 60 goes into that twice on the top and 3 times on the bottom. It's the same answer. So we now know that theta can be, and make sure that answer is in radians, pi over 3 or 2 pi over 3. And there is our answer for number 7. Okay? Now, if you think you're doing really good at these, or think you know at least part of it, take a moment, pause the video, try number 9, then come back and see how you did. Okay? Try it. And if you only want to try a little bit at a time, do it step by step. Do you solve for tangent correctly? Do you find the right reference angle? Did you find the right quadrant? Whatever works for you. Okay? So, pause if you want and try it. So here we go. Let's solve this. I'm going to subtract the tangent of theta from both sides. And this will give me 12 equals 1 tan theta plus 11. Now I'm going to subtract 11 from both sides. So 1 equals the tangent of theta. So we need a reference angle. The tangent of what angle is 1? Well, that's 45 degrees, but remember, our domain was in radians here, right? And you might want to, when we go change pages, you might want to add this at the top so you remember what kind of answer you're supposed to give yourself. So now we need to look at the fact that we know that the tangent is a positive one. So all students take calculus. We know tangent can be positive in quadrants 1 and 3. So quadrant 1, we like that. That just is our reference angle. And then quadrant 3. So if we're in the third quadrant, that means we went pi over 4 past pi. But pi needs to be written with that same denominator, so it's 4/4, 4 pi over 4, plus the 1 pi over 4 that we went past it, that's 5 pi over 4. Or, if you're working in degrees, you went 45 degrees past 180 degrees, so that would be 180 degrees plus 45 degrees is 225 degrees. And then take your 225 degrees times pi over 180 degrees. Now 45 is going to go into 225 245 times, and 45 is going to go into 180 4 times. So we are going to get the same answer. And now we know that theta can be pi over 4 or 5 pi over 4. Now there is one more I'd like to show you. And we are still dealing in radians, so our answer is going to be in radians. Do you notice what's different here? The trig function is cosecant. That's a reciprocal function. Is it going to make the problem more difficult? Let's find out. Okay, let's subtract cosecant theta from both sides. So that'll give me 2 cosecant theta plus 5 equals 9. We're going to subtract 5 from both sides. 2 cosecant theta equals 4. Divide both sides by 2. Cosecant theta is 2. Now, here's the one step that's different. I don't have all my values for cosecant theta memorized. Do you? No, but I do know that cosecant is the reciprocal of sine. So if cosecant is the reciprocal of sine, and cosecant of theta is 2, that means the sine of theta is the reciprocal of 2 or 1/2. Now we can do exactly what we were doing in the previous problems. So we find our reference angle. Sine of what angle is 1/2? That's 30 degrees, or in radians, pi over 6. And then we say, okay, all students take calculus. Sine is positive in the first and the second quadrant. So the first quadrant is easy. It is our reference angle, pi over 6. In the second quadrant, that means we are pi over 6 before pi. And with the same denominator, that would be 6 pi over 6. So 6 pi over 6 minus 1 pi over 6 is 5 pi over 6. If you're working in degrees, you're saying, okay, I'm 30 degrees before 180 degrees. So it's 180 degrees minus 30 degrees is 150 degrees. And then 150 degrees times pi over 180 degrees. So 30 goes into 150 5 times, and 30 goes into 180 6 times, and we get the same answer. So now we know theta can either be pi over 6 or 5 pi over 6. Please do not tell me that the answer is 30 degrees and 150 degrees. This is not correct because we were told that's our domain. So you need to watch your domain, watch all your steps, and we will practice this more. Have a good day, guys.